So it is 16 March 24th, OOP345 NAA. Make sure everything's set nice. Okay, so we are going to talk about multiple inheritance today, and then we're going to move to other things. The order of the things that I'm going to talk about is exactly not what is stated in the schedule, but it doesn't matter which one goes up and down. Before we actually switch into non-object-oriented stuff, I wanted to finish C++, which is multiple inheritance, and then we're going to go to macros and all the preprocessor directives, which is essentially C. It has nothing to do with C++, and low-level binary stuff. Before we begin, I have two people online, and you guys are here, so just checking to see if any questions before we start. Any particular thing that you're interested about? Question? Any question? Any question, my newcomer friend? No questions? No questions, all right. All right, well, by newcomer, actually, I meant somebody who just newly got into the class, not newcomer together. Anyways, yes.
I just have a question about the last class Friday.
Mm-hmm.
I didn't check yet, that's on me, but did you discuss anything in class after the quiz?
Oh, yeah.
You continued on multi-processing.
Yes. So the notes should be up, if I'm not mistaken. Let me double check. I don't want to, because sometimes I forget. But I know that I uploaded the video immediately after. So I'm just going to do a commit over here, make sure if anything's missing. No, it's just today's. So it has been uploaded. So I'm going to say March 24th init. So the Git is updated. Everything's there. You can just review the, look at the video and the notes. Talking about multiple inheritance, I gotta tell you what does it mean actually multiple inheritance. So let's start with a simple example, and it's going to be pure syntax. So you know what inheritance is. I'm not going to, whatchamacallit, let me just bring these over here. The syntax is the same. I just have to tell you what happens when you do multiple inheritance. So we're going to go through example one by one. I'm going to literally call it B1, B2 as base 1, base 2, and go like this, and then derive so we can see exactly how multiple inheritance is happening. But before doing that, I just want to draw something in here and show you. I hope this, yeah. Okay, I left it last time. It's still here. Okay, so I'm going to actually draw something for you and kind of explain what we want to talk about here. All right, so when there are two different things that we are doing. It's when we are doing it, when we are drawing a diagram of what the system looks like, we have two different types of things. We have object model, the dynamic model, and we have, no, let's put it this way. We have a class model and we have an object model. Now, what is the difference between class model and object model? The class model says, this is the design that I have in class, and I have over here an employee. An employee has this attributes and his classes. So this is what you have. That's your class model, right? But the object model of your, so the class model says I have an employee. The object model says I have 50 employees, object of type employee created. Each one of is E1, E2, E3, and E4, okay? And then it talks about this relation and how it's going to work out. So the object model says how the classes are instantiated in your program. Do we understand the difference between the two? Okay, so the class model tells you how the classes are inherited from each other and the relationship between them. This one, the object model, which is essentially a dynamic version of instantiation of your classes throughout the execution of your program, tells you what objects are created while your program is running. Are we okay with this? All right.
Excuse me, Fardad,
Yes.
are you sharing your screen right now?
I think I am, but let me just do it one more time. So now I turned it off. Now I am turning it on again.
Okay, there we go.
Okay, all right. So I think I have to, something's fishy these days with that. So, so as I was mentioning, so for those of you at home, that we have two different types of diagrams with respect to the classes that we have in a program. We have how your system is designed. So we have the design of the system, and let's actually. So we have the class diagram of the system, and then we have the object diagram of the system. So the object diagram of the system tells you while your program is executing how many objects of the class that you have designed is actually playing in your application. Okay? The class diagram tells you what is the relationship between classes in your program. With multiple inheritance, I have to mention this to tell you why we are in trouble when we do multiple inheritance. So you understand the difference between when I say a class, this is the class diagram, understand how that's how we designed our system. When I say this is the object diagram, which means how it is actually instantiated while the program running. We good? We good, Victoria?
Yes.
All right, okay, so I can get rid of this now. So when you are doing multiple inheritance, what are we doing? We are actually having two classes. One class, I call it B1, and I have another class over here, I call it B2. So B1 and B2 are two different classes that I have in my application. And out of this ones, I can actually, now take a look at the code over here. I have class B1, and I put some data in it with some, you see, methods created just to show you how things work. And yeah, so it has a constructor, it has a destructor, and it has a show method that shows something, and an operator that actually is overloading B1 to be displayed on the screen. And I have B2, the same thing with data, but it's B2, so it's identical to that one. It doesn't have to be identical. I just want you to know that we have different objects over here. And then I am deriving from B1 and B2 at the same time. Therefore, the class derived has two parents in a same level, B1 and B2. As you see, the syntax is identical to regular inheritance, which means you instantiate the B1 part and B2 one, and so everything works the exact same way. The syntax is the same. It's as if you have, the only difference is that you actually have two base classes over here that you're initializing as you're going through it. Very simple and straightforward. And in my show, as you see in the derived class, I'm showing the B1 show and B2 show. Therefore, I can call the different base classes that I have, and I can return whatever I have in here. And the program running over here, definitely I cannot, if I have a derived D over here, and I go C out D, because I did not overload anything to show D, it's going to cause an error. Because two different types of operator overloads I have for B1 and B2. One inserts B into O stream, B1 into O stream. The other one inserts B2 in O stream. Now, if I want to use virtuality as I used before, and I say, okay, I'm going to actually print the derived one just with C out, compiler doesn't know which one to choose. But as soon as I cast it to one of the two, then everything is okay. Am I making sense? Okay, so essentially what I'm saying is that I have B1 and B2, and in here I am inheriting these two into derived. Okay, so if I create an instance of type derived, I have overloaded this one to work with OStream, and I overloaded this one to work with OStream again. So this is B1 that can go in there, and this is B2 that can go in there. And in here I have D. If I say C out D, compiler doesn't know which one to pick because they are equally suitable to show everything because of virtuality. So it's kind of a collision between the two. But as soon as I cast this D of mine to one of the two, so if I say B1 reference D, now I'm good because now it knows which path to take. Okay? And it will run. So that's the first problem with multiple inheritance. You have to be careful and see how virtuality is taken care of. And that's one of the reasons that when you are working with IOStream, you'll see that you have seek G and seek P. And for different types of input and output, they don't decide to have the name seek and then automatically pick the proper one. There will be confusion. Because of that, they say, the heck with it, we're just going to separate the two. We're going to name them similar so we understand seek P is for P for putting for output, and seek G is for getting, and that's for input. Okay? So that's demonstrated over here. So if I run this program, you'll see that it works properly, and it actually prints the thing twice, as you see, perfectly. But the problem over here is that if I bring this one up, then the compiler is confused and doesn't know which one it's going to actually deal with. It doesn't know which one to pick up. Look at that. Okay, so more than one operator matches the operands, and I don't know which one to pick up. And because all the IOStream stuff are heavily templated, because of that fact, the error messages that come out is pretty crazy. Okay? So that's, well, I picked it up by mistake. Let's put it back. So that's the first thing about multiple inheritance. So multiple inheritance, CP. Okay. Now, if you think this is crazy, now imagine what happens if I have something like this. So now my class diagram goes like this. Take a look. I have a base. Now out of base, I inherit two different objects. B1, two different classes. and B2. Okay? And then, out of these two, I inherit another one that is derived. Okay? When you just look at, when you only had this one, when you only had that one, let's assume base is not there. The object diagram of drive, when you actually say derived D, the object that is created contains derived, and it contains B1 and B2. Are we good with this? That's the object diagram if I only had this one and I didn't have the base up there. So when you actually create an object of type derived, it's going to have the derived in here, which all the data, it has a B1 and a B2 in it. So all these three classes exist in a derived object. Are we good with this? All right. Now the question is going to be this. When I create this one, how does it create the object? Is the object created as this? Is the object created as this? Or the object is created as this? Think about it. When you have this inheritance, I'm just going to focus on different aspects of inheritance over here. If I only had this part, if I only had this part, if I created B1, B, what I would have would be base and B1, correct? If I only had this one, then what I would have if I say B2B, then it would have a base and a B2, correct? Right? So if I have the whole thing, logic dictates that number one is actually the one that's going to get created. Because when it creates B1, B1 has base in it. When it creates B2, B2 has base in it, and derived will get created. Right? And that's actually what happens. But that sucks. What if I have base as a window, and I have at left and right, one is a dialog box, and the second one is a text editor, and the inherited derived, I want it to be a dialog box with text editor in it. Then the coordinates of the derived one, which is in window, will be 2, will be duplicated. Where in the screen it's going to be? And sometimes you actually want this one, number 1. Sometimes you want 2 different things because this one is the left thingy and that was in. I can come up with 50 different scenarios that you want 1 and another 50 that you want 2. Okay? There is a way to actually enforce that. To tell to compiler which object you want to get created when you're actually instantiating. Okay? And I'll tell you what it is and what are the consequences for it. Okay? So again, first I create the problem, then I'll tell you how the problem is fixed. Do we understand exactly what the problem is here? Hopefully? Pardon me? Yeah, exactly. Do you want, and this is not the only thing. Just now, the problem even gets bigger. Just think about this now. What you going to do now? What if you want your object to get instantiated like this? B4 with a base and a base for these three and derived. What if you want these two to share a base? And what if you want all of them to have the same base? So it goes bananas. That's why they hate C++ because of its multiple inheritance. In many languages, they don't allow you to have multiple inheritance in it because they say it causes trouble. It makes the design extremely complicated. Okay? And complicate things is not what our brain is very good with. Okay? We're good down to this point. We understand what the problem is? Okay, so let's try and see how we can actually implement and fix this problem as we are going through it. So in this case, as you see over here, I have the base, and I have B1 as base and B2. And just to show how things work, I am passing, so I'm essentially passing one value to the base. So let's recognize that the constructor of base. The base is defaulted to 0. It means that no argument for base makes that a 0. Or you can pass a value to it. That'll be good. And B2, it's the exact same thing, but I'm doing over here, I'm adding 1 to it so we can recognize which one is what. So B1 will be adding 1 to it, and B2 will add 2 to it. Are we okay with this thing? And then we have derived one that I'm adding 10 and 20, so the values get bigger, so I can exactly know which one is what. Are you okay with this? And the show over here is showing everything. It starts from the base, and it keeps going forward. Okay? Which we are going to see the consequences of it. All right. So when derive is getting created, as you see, okay, now it comes over here and goes to the constructor of B1 and B2. So B1 and B2 want to get created. It goes to B1, okay, and when it goes over there, it actually initializes base to 21. So it adds 1 to it, right? And it's done. And therefore, B1 is created. And then it goes, what did I do? Oh, B2, yeah. I thought I deleted something. Okay, so I go to B2, and now in B2 it creates the base of B2 as 32. So we have two different bases, obviously, all right? And then it's going to mention exactly what is what. So we're going to come over here. And the reason that I'm showing the addresses in front of them, I want you to actually see where they are sitting in memory. So we know if the bases are the same or not. Okay? So as you see, the bases are created, and did I? This is base, correct? All right. Okay. And let's continue. So now I go back and I have the derived one. So as you see, derived gets the 10, passes 20 and 30, 21, 22, and so on and so forth. We good? All right. Now, the derived is created over here, and I want to show them one by one so I can show it from two different places. So I'll show it to you in a second. So now when I'm going from that direction, I'm saying show B1. So what happens, it goes to the overload that is for B1. It goes to the overload that is for B1. And therefore, the show for it will show the base of B1, and it keeps going like that. You see that? Got it? So the base show at this moment, it's showing the base from the B1 side. Okay? Think about marriage. Husband and wife, each one has a parent and mother. Okay? So if you want the husband invites everything, grandparents of husband comes. Okay? When the wife invites, the grandparents of the wife will come, right? So think of it that way. So whoever does the show, it shows the parents of its own, basis of its own. And that's that. So, and when I show the second one, it's the exact same thing, but it goes to the other one. Okay? So, how can I, and let me just do this too. Save this. So this is it's diamond inheritance. When I say diamond, you know what I mean. This is exactly. So what happened? Can you guys, oh, no, something got connected and disconnected. I hope. People at, online people, Victoria, can you hear me?
Yes. Yes.
Okay.
Oh, yeah.
Because something got disconnected and connected. I don't know what happened. Okay. So when I say diamond inheritance, this is what I mean. You see, it's a diamond. Okay? But the object is not diamond. When the object is created, it's parallel. You follow what happened? So the inheritance is diamond, but the object created out of it is not. Okay? Different bases. Now, what you can do is this. This is the exact same thing, but look at the inheritance over here. What does it say? It says class B1 virtually inherits base. When you have virtuality in functions, when you have a function method that is virtual, we only say virtuality only comes to play when you have a child class pointed or referred to by a parent's pointer. Do we understand this? You remember that from virtuality? In virtuality, for virtuality to come to play, so you can actually think about if this virtuality is important or not. You must have a child pointed by a parent, pointer or reference, and parent has a virtual method. Then you can actually think about this is virtual or not. Otherwise, if you have a child pointed by a child, who cares if something is virtual or not, right? It's the same thing over here. So virtuality only comes to play in virtual inheritance when you have a grandchild. When you don't have a grandchild, when I say class B1 virtual public base and I create an instance of B1, that virtuality means nothing. It's just regular inheritance. Nothing happens to the base class. It's exactly as if you don't have virtual. Okay? Virtuality comes to play when the grandchild is actually instantiated. When you, two things happen when you inherit something virtually. Okay? Number one. If you have several siblings that are virtually inheriting the base, when I say several siblings, this is what I mean. If this inheritance was done virtually, and this inheritance is done virtually, so several siblings inherit virtually, all of them, not one of them, as we have in here. This one is virtual, B2 is virtual too. They are both virtual. When you have something like this, then the bases come together. You have only one base created. Okay? That's number one. So number one thing that happens when you are actually inheriting something virtually is that when you have several siblings with virtual inheritance from the base, they share the base. Immediately something comes to mind. Wait a minute. B1, it says base V plus 1. And B2 says V plus 2. Which one will be called for the base? Didn't we just put them together? Didn't we say that when they are both virtual, then the class created will be like this? So I have one base, and I have B1, and I have B2, and I have the derived over here. If one base is created, and B1 says pass V plus 1 to it, and B2 says pass V2, and B1 maybe get created with some different initial value. B1 is created with 30, B2 is created with 50. How does the base get created? The answer is that whenever a virtual whenever a class inherits from a base class virtually, when a grandchild is created, no matter how you request it, base will be defaulted, which means no argument. Even you pass 30 to it, its default constructor will be called. You cannot decide how to set it because constructor is to build the class, make the class into an object. And you cannot say build it in two different ways because it's one action. And the only common action between all is a no argument constructor. There is no other choice. Because of that, it is forced to get created the same. Now, if you want to change its properties, by all means, do it in the constructor's body. There is no problem. You cannot initialize it. You have to set it goes back to OOP244. Initialization means at the moment of creation, an object is created with the values inside. You don't set it after. It's not that it first becomes something and then you set it. Yes?
So in this case, then, base cannot be initialized with any value, but can be set to value.
Yeah, so in your constructor of B2, you can say add to value of base or overwrite it, whatever. So B1 and B2 can do something to the value of base afterwards. Of course, if one set did something and the other one set it too, one will overwrite another. And depending on compiler, you don't know which constructor is calling first. So you'll be in trouble. Okay? It's exactly like multiprocessing thing that you don't know which one is going to do what. And depending on compiler, depending if it's C type of function called Pascal, one is using Q, the other one using stack. Q is first in, first out. First in, first out. Stack is first in, last out. So, for example, if this is real, try it on your computers, okay? Create a function called foo, okay? And have something like integer a in here, and pass a plus equal to, and a plus equal to. Pass something like this to a function. If a over here is 10, some compilers will pass 10 and 12. Some compiler will pass 12 and 12. Why? Because some compilers push this one in first, and then this one, which means 10 and 12. Some compiler uses stack, which means last in will be first out. Therefore, last one will go in first and comes backwards. Therefore, you're going to have 12 because this will happen first. Because of that, you can never guarantee it. The same thing happens when you're actually doing this. We don't know if data is going to get initialized first, then B1 or B2, or B2, B1 data. Depending on compiler, it may change. And I don't know, maybe they standardize it now, but I'm an old guy, so I had those problems, those bugs all the time. So if that's the case, you need to have a strategy for it, okay? So by what I told you right now, as you see, there is no need over here to base show this, base show that. They're all the same base. And when we run it, you'll see it. Yeah. I'm not going to bore you with walking through it. You'll see exactly what it is. So as you see over here, base is 142. It's not two different ones. Look at this. Look at the addresses. You see that? They're identical, which means one base, not two different ones. Even if I call it from base 1 or base 2, they are sharing the same thing, therefore no difference. Pardon me? Oh, this is base. This is the derived one. This is the base. It's the same for both. So it's one base for both. Okay? So yeah, just keep that in mind. And that's it. So there is nothing else to talk about in here other than this. But one thing you need to remember, again, nothing happens automatically. Walk through this and you'll see exactly what I'm talking about. Have different type of addresses printed in it and check it to see which one is what. When you have two virtuals, the bases are always identical. They overlap. One thing it's important to understand. So this one is So this is diamond inheritance and diamond base at the same time, which means the bases overlap. Okay? What I want to show you is this. One of them is not virtual, and the other one is. Based on what I told you, what happens over here is that you're still going to have parallel, which means you're going to have two different bases. And one of them will be defaulted. There is no way for compiler to know if you have 5 different virtuals or not. It doesn't. So what I'm saying is that when you create it like this, when you don't put the V over here, when compiler is building this, it doesn't know that this one is virtual or not. Therefore, because you made base 2 virtually inheriting base, when you are deriving it, from this one it's going to be defaulted, from this one is going to be regular construction. And the end result will be 2 bases. And this one is default base. Be careful. And that's how you choose. So if you have 4 different things inherited, and you want 2 of them to share a base and 2 of them don't, then you cannot do it like that. You can have several of them share and the other one don't. You cannot have 2 of them with 1 base and 2 of them with 1 base, because all those who are virtual will overlap. Okay? Yes?
So, just my question is like if there's B1 and B2, right? And both of them are virtual.
Both of them are virtual.
Yeah. And then the B3 is not virtual, so it's going to write its own path.
Exactly. So B3. So B3 will have its own base. So this one is going to be defaulted. And this one is going to have a construction. So in any case, you're going to have, but the thing is that, okay, let's put it this way. I'm going to give you an easy way to go out. You have a base, okay? You have B1, that is virtual. B2, that is virtual. B3, that is virtual. B4, that is not, and B5, that is not. And then you have a derived one. First of all, if you don't have a derived one, who cares? The virtual doesn't work. If I instantiate B5, I have a base. If I instantiate B2, I have a base. Virtuality doesn't work. But when I have D over here, and I'm actually instantiating D, in this scenario, I'm going to have 3 bases. 1 for these, which is defaulted. Exactly. This is defaulted, and 1 for this one, and 1 for this one. And it doesn't matter what is the thing. If you have it like this, then these 3 will have a default, and these 2 will have separate. Well, it's not like it's in sequence. Just be aware. And that's all. That's all you need to know about. And consider and remembering the fact that nothing's automatic clears everything up. If you have virtual and you have grandchildren or grand-grandchildren's instantiation, remember, the virtuals are always defaulted and they overlap. That's all. That's all you need to know. And anyone that is not virtual will create an own base. Yes?
Can you share an example why we need, on some cases we would need different bases? Because each object B1, B2, B3 are already unique, right? So I don't see why we need 2 different bases.
I'll show you 3 seconds. right? The base is a window. The left bar is a window. The right one is a window. You have different coordinates. If you want to design this, you want two different bases. One with the coordinates of this one, and the other one with the coordinate of that one that exactly sits beside this one. And the right coordinate of this one should be the first coordinate of the right one. So therefore, when you go back and forth, they all match each other. You need two different bases. But they're all in one window. Yeah, I'm just making it up. Maybe it's not designed that way, but if I would design it, I would go that way. And it's not your job to think about it right now. It's the system analyst's job. The person who designs it tells you that. Okay. For now, you're just supposed to. So when you come to analysis and design, then you're going to see when do you need that. Okay? And sometimes you would say, don't. Don't do multiple inheritance. As easy as that. Okay? I think Java actually goes over it by only having interfaces. So you can actually have multiple inheritance if parents are interfaces, which means that you cannot instantiate them anyway. You know what I mean? So if you actually make the base class an interface, you have no problem. They're always shared because they don't have any properties to do it. You know, they're just pure interfaces. Okay? All right. That's that. So that's multiple inheritance, essentially. I don't know what to call this. CD. I'll call it half virtual. Half virtual. Pardon me? Version is going to be confused by different versions of the source code. All right. We good down to this point? Let's take a 5 minutes break so I can type stuff over here. Okay? So 5 minutes break, and I'm going to do this. Oh. I need to do it from here. So. Pardon me? Really? Okay. So how do I put a 0? 1, 2, 6. I'm trying to. We need to go to binaries, right? That's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 binary. Pardon me? Binary, actually, yeah, but I put hexadecimal in front of it because, yeah. Anyways, yeah, I'm going to write some code for you so you actually see how things are happening in here. Start in 2 minutes. You have till 3, I keep forgetting if it's 3:15 that we enter or 3:20. I'm always confused. It's an awkward thing when it's 50 minutes each. Where are my, oh, and I'm recording. I didn't pause. Shoot. Yeah, at least you can see how to write these things quickly. In final, if I give you a question, I'll give you this bit pattern, so you know what they are. Let's talk about bitwise operators and understand what they are and what they do. Okay, all right. So when you're dealing with bitwise operators, you know that each byte has 8 bits, and you know the story behind it, right? You know that. How did it come to be 8? Anybody knows? You know how did it come to be 8? Why not 10? I don't know. Okay, so when the original computers came out, there was this wires that you had to pull in. So essentially, bits came to be the only way they found out that they can actually hold this information inside a computer was with a flag. It's as if you have a light in at the door of your house and say, if the light is on, I'm in. If the light is off, I'm not in. You're essentially saving a state. Any switch that you turn on and off, you can show 2 things in it. Okay? You want sugar or you don't want sugar. Okay? I want red or blue. If red or blue are the only choices, then the one switch is enough to show them. If I tell you red, blue, orange, or green, then you're in trouble. You have 4 of them. For 4 of them, how can we do? The best way is to minimize the number of switches is to use combinations. So if you only want 2 things, you need 1 switch. If you want 4 things, you need 2 switches. If 2 of them are 0, that's 1 position. If the first one and second one, that's the second position. That's the third one, and that's the fourth one. Hence, you have 4 different situations you can show. With 3 switches, you can show, with 3 switches, you can show 8 positions. So right? 0, 1, 2, 3, 4, 5, 6, 7. Right? And with 4 of them, you have 16 different positions. Right? Now, if you want to code the alphabet is not kept in a thing like that. They add a code, and then they show the shape of the code, right? That's how it is. So they save the shapes, and they put some code for it. So how many letters in the alphabet? 26? Okay, 26. This is 16. So if it's 5 of them, that's going to be 32. So that looks enough. Well, wait a minute. How about lower cases? So let's make it 6. That's 6 is what? 64? How about spaces, dashes, and things like that? You add those. Let's make it 7. So you put 7, you have 128. Fantastic. But 7 is not symmetrical. 3 at one side, 4 at the other side. That's not going to work out, right? So let's add one more, 8. And now we can actually put everything in it. 256 different things from 0 to 255. That's a byte. That's how bytes came to be. And that's why you still have problem when you're doing F to say ASCII or binary. It's because the old systems still work with EBCDIC, not ASCII, which is essentially 7 bits for a text. And they ignore the left one, the 8th one. And that's why when you transfer with binary, transfer as text from Windows, that is essentially the old-fashioned thing, to Linux, you're going to be in trouble. The files are going to corrupted. You see that the things are not going right. So you have to make sure everything's safe ways now. Everything passed by binary. You're fine. You'll be fine. Okay. Well, anyways, you follow what I'm saying, right? And why hexadecimal? Because it's easy to show contents of a byte with 4 of them. 2 of these together become a byte, right? So they say, let's flag them. We're going to put over here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 is 1, 0. That's confusing. So I'm going to put A, B, C, D, E, and F. Therefore, hexadecimal. So when you say A2, essentially you mean 1, 0, 1, 0, and 0, 0, 1, 0. That's the content of the byte. Therefore, with 2 letters, you can show what happens inside the byte. Perfect thing to actually show the memory content. That's why memory content is shown with hexadecimal. You follow? Right? And that's why we had all those binary things. When I show the binary, it shows hexadecimal, hexadecimal. So it's essentially showing the bit pattern to you. Instead of showing 1s or 0s, it actually shows the bit pattern using hexadecimal. Are we good?
Sorry, Fardad, we
Yes.
can't see the screen.
What the heck is wrong with this thing? Oh, God. Okay, sorry. Can you see it now?
Yes.
Okay. So I hope you got what I said with all the things that you see on the screen. So essentially, the quickest way to draw an ASCII table, a binary table, is to put 8 zeros, 8 ones, then reduce it. It's recursive, right? Then 4 zeros, 4 ones, 4 zeros, 4 ones, then 2, 2, 2, 2, 2, then 0, 1, 0, 1, 0, 1, and automatically you're going to have from 0 to 16, the bit pattern is shown. Any value that you find out in a computer, you can show with 2 digits hexadecimal. Okay? So here we go. So let's see what are all those good things that you see. So the very first, so A2. So let's say I have a character C equals to, how do you write hexadecimal? 0x, and then we write over here A2, right? Sorry, my X is awful. There we go. So I do that. Very first thing that you need to know. If I have over here, and let's say I have character B. So if I write over here B is equal to C, that's not insertion operator. Insertion operator is an overload of a left shift operator from C language. That means shift the bits in C 1 to left. Essentially, it's as if somebody's standing over here pushing things 1 to back. And that one drops into garbage. That's the left shift operator, not insertion operator. Insertion operator will be lied to you in OOP345 just to put a name for it. That's actually left shift operate. So if I do this, everything's going to be shifted to left. Therefore, you're going to have B is going to have the content 0, 1, 0, 0, 0, 1, 0, 0. So it shifts and fills this thing with 0. Therefore, B will have the value 4, and this one is 4, 4, 4, 4. Sorry, when I walk through, I really switch off my intelligence. That's why I do that. So it's 4, 4. So if you actually have A2 and you left shift it, it becomes 4, 4. Okay? Are we good with this? So let's write it and see what happens. Give me a second. Okay, so forget it. I want to bring that way. We don't need it. Okay, so let's come over here. I'm going to have and we're going to have what do I have? I'm going to write over here int okay. So I'm going to say character ch is actually, let's go unsigned character ch or c, and I'm going to set it to 0 xa2. Okay. First, let's see if I can remember. So it's C out. Let me put these up. Using namespace std. No. How did we do it? Oh, because it's character. Sorry. That's it. A2, and then it was std uppercase, if I recall correctly. I just want to show it once that remember what it was. So it's A2, so good. Just wanted to, okay, so that's the value, and it's hex, and I'm going to show something like this. It's going here too. So what do I do when I want to go back to decimal? Was it decimal? std, if I recall correctly. Yeah, okay, good. So A2162, right? So that's the thing that we have over there. Now I'm going to write the code over there and see what happens if I write over here, and I'm going to create a B over here. I'm going to write exactly what I've written over there, which is essentially B is set to C left shift once. Okay? And show the exact same thing, but with the value of B. What is that value? Okay? Okay, so essentially, when you left shift, okay, now, I'm going to, instead of character, I'm going to put over here int so we don't have to worry about the values. I don't want to go back to int over here. It's the same. It's just going to be bigger. Now, the last one will not go to garbage. Okay? And now what happened? Any relation between the two? I left shifted, and the last one did not go to garbage. It's an integer, 32 bits, right? So it shifted and went over there. What happened? It doubled, right? Now take a look at this. Now what happened? Divided by 2. So essentially, a left shift and right shift is a multiply by 2 and a divided by 2 as a bit pattern. You don't believe me? Do it, and you'll see. Okay, so when you actually divide and you go, that's what happens. So what many of programmers, when they are doing graphic card programming and stuff like that, when they have to do multiply by 2, multiply by 4, multiply by 8, things like that, they rather do left shift because it's much faster than adding. Shifting stuff, our bitwise operators are the fastest operations that CPU can do. It's like CPU's natural thing, okay? So keep that in mind. So you will see that people say, when I want to do a left shift, I divide by 2. When I want to do a right shift, I divide by 2. When I want to do a left shift, I multiply by 2. That's the thing for it. Are we okay down to this point? So, and if now, I wish I could actually show you the patterns inside this with ones and zeros. I wish there was something that actually show it in binary. We don't have that. We have to write it ourselves. And how do we do that? Using the next thing. So left shift and right shift, you know what it is now. So if I do right shift, it's as if you put your hand over here and you go to right, okay? This is a very iffy situation, and I'll tell you why soon, okay? Why, when you right shift, the values are different when you left shift. I'll show it to you soon, okay? How can I print the contents of the bit pattern inside something so I can see ones and zeros? First, we have to understand and or. Okay? And between 2 bits, not bytes. So let's say this is C. In here, I'm putting a character because it's quicker. When I'm doing it over there, I'm going to do it with an integer. Okay? So, excuse me if I'm doing 8, not 32, because I don't want to keep going with zeros and ones. So this is C. And let's say B is 0, 1, 1, 1, 0, 1, 0, 1, something like that. Okay, so 0, 1, 1, that's 7. Okay, whatever it is. So this is A2, if I recall correctly. So this is gonna be 7 and 5, right? Now, if I say D is equal to B and C, 1 and, not 2. That's bitwise and, which means the bits one by one will be anded together, if that's the verb. Okay? So essentially you're going to have 0 and 1, 0. 0 and 1, 0. 0, 0, 0, 1, 0, 0. That would be the value of that one, which is it's 2, 0. We good with this? Now, if I say D is equal to B or C, it means doing or between. So essentially, this is going to be 1, 1, 0, all ones. 1, 1, 1, 1, right? Which is going to be F and 7. Are we okay with this? We understand how and or works? Okay, so that's why when you forgot to put 2 ands and you put 1 and, the result is usually true. Because true or false or whatever it is, it's not and or, because the result is just another integer. It's not true or false, because all the corresponding bits are going to be anded together. Are we okay with this? All right. So we understand what and or is. Now, let's say I have this value over here. What is this? This is 0, 2, correct? If I AND these two values, what's going to be the outcome? Right? It is not equal to 0, correct? Right? Now, if I AND these two, what's going to be the outcome? So this is not 2, it's 4. Right? It's going to be 0, 0, 0, 0, 0, 0, all 0, which is equal to 0, correct? Are we okay with this? Do we understand this? I just found a way to find out what is the content of a bit. All I need to do is to create 1 and all zeros and AND it. If the value is non-zero, the result, that bit was 1. Then I shift it 1 to right. I AND it again. If the result is not 0, it's 1. If it's 0, it's true. It means I can find out if this is 1 or not. Then I'll shift the 1, 1 forward. Now I can check that one. I'll keep going until this becomes 0, which means I don't have anything in it anymore. So I keep shifting until 1 reaches to the end, and I print that. I shift 1 more time. This is going to go to garbage, right? They call it bit pocket. It goes to garbage. Therefore, it becomes 0, right? Are we okay with this? Now, how can I find out how many times I have to shift to left? So let's write the code. I want to find the bit pattern of an unsigned integer. I want to write a code to print a bit pattern of an unsigned integer. So it's going to be void bit pattern of unsigned, and I'll tell you why I'm saying unsigned. Int whatever value is. Okay? So this, I call it a mask. Okay? That mask essentially is a mask that you put over a value and see what it's going to look like. Okay? That's why they call it a mask. So I'm going to call it, put over here unsigned. Int mask is equal to, what do I put over here so left one becomes 1? How many times? So first of all, it has to be a 1. When I put 1, it's 0, 0, 0, 0, 1 at right, correct? I have to move that 1 all the way to back. How many times I have to shift this to left? Huh? No, it's an integer. Integer is not 1 byte. In some computer, it's 8 bytes. In another one, it's 4 bytes. Huh? Size of. Okay, size of what? Size of unsigned int, correct? Is that correct? Your -1 is correct, but your size of sucks. Size of is number of bytes, not bits. So you have to multiply it by 8. It tells you how many bytes, right? So in here, I'm going to say multiply by 8. Now that's the number of bytes. Now the smartness kicks in. If I actually shift it 32 times, it's going to fall off from the other side. So I have to go 32 minus 1, or 64 minus 1, minus 1. And therefore, that m of mine will be 1. Correct? Are we good? Now I'm going to say while. That m is not null. Why I have something in m, right? I'm going to say cout. Not, who's there? M and value. And cout and L. And afterwards, I'm going to say shift M, 1 to right. What not means? Okay, let's say the leftmost bit is 1. So it's a huge number, right? First not means not value. Value means true. So it makes it false. The second not makes it, so converts any non-zero value to 1. And if it's 0, not 0 becomes 1, and not 1 becomes 0. So 2 nots simply converts it to 0 or 1. So if I want to show the value of C now, remember I actually created something and I said this is a manipulator. I created that composition and I showed you how to create a manipulator, how to write your own custom manipulator. Nobody saw the source code for that, did you? I said go study it. No, you didn't. Okay. For when I was teaching composition, I created a library and a book. And for library and a book to show the details, I created a manipulator that you put it in cout and it hides the contents. So you can write a manipulator that actually prints. So you can create, let's see, hex. You can do something to print binary if you want to. But anyways, so in here I'm going to say, well, let's go to new line actually. And I'm going to say bit pattern of C. And see if it's going to actually work. We'll find out. There you go. Is that what I have over here? Right? See? That's it. So now we can actually see what the bit pattern is. Now, how can I make this separate by 8? How can I do that? So every 8 things that I print, I have to print a space, right? Okay. Yeah, I'm just, you can play it. I'm not going to go too crazy stuff. Just going to write a counter over here. I'm going to say int CNT is 0, 0. And I'm going to say over here CNT plus plus. If CNT plus plus is equal to, what is it, 8? Is that correct? Or I'm wrong? If it's 8, it means I printed 8 or 9? 9? Okay. So if it's equal to 8, then C out. Make it shorter if you can, please. Thank you. C out a space, put a space over there, and CNT becomes 1 again. Right? Let's see if it's going to print spaces between, or we did it wrong. There we go. So now I have it separated in 8, so I can actually see what the contents are. Are we okay? So that's a bit pattern. Now I can actually try and see how different things work. Okay? For example, after all these left shifts and right shifts and things that, so in here, this is C. Gonna go B. Here we go. Now we can actually see how left shift and right shift are working. So this is essentially left shift. You push it over here, everything goes right, and it's going to do it that way, right? And the other one comes. Are we okay? We good? Okay, now I'm going to show you something interesting. Now that we have something that I can actually show you the values and all the good stuff that I have, I'm going to show you this. Let's make it an integer and see if it works. We're good, right? Same thing. Are we okay? All right. Okay. See? It's all F's, all ones. What is less than 0? There is no negative numbers in C language. Everything is positive. That's why they simulate it with 2's complement. Did you go through 2 complement at the beginning, at semester 1? This is essentially what it is. Okay, so that M that I printed over there was a big negative number, actually, that M thingy that I had. So if you actually shift, so in here, if I actually write, what is the, so if I have a 1 at left, what is it going to be? 8, correct? So it's going to be 8F8. So essentially what I created over there was 8, 0, and then 1, 2, 3, right? That's what it is, right? So if I do this, probably what I'm going to have over there is a 1 at left side, right? You see that? But what is the value? That's the biggest negative number, positive number that you can have. Is it positive or negative? I'm a very bad person. It's actually a negative number. Give me a second. I use the stupid thing over there. Control H. And I'm going to say like that. And I'm going to change it to, what do I put over there? So we can, can do it. I'll do it like this. Okay? Why didn't it change all? Thank you. Okay. Boy, it crashed. Okay. There we go. You see that? Now see what happens if I do this? If I go. Sorry. You see? You go one less than that's 2's complement. So if you add this one to this one and reduce it by 1, then that's plus 1, then that becomes 2. So this is the 1 less than that. Okay? Should I teach binary operations? Everybody looks confused. You should know this. You did binary operators in semester 1, right? You did? No? Okay. Yeah, everybody's looking confused. So let me tell you this. Yeah, this is the best thing to. So I'm going to say over here 2, okay, and I'm going to say b is equal to minus b, okay. So this is 2, this is minus 2. Okay? If you add the 2 together, what's going to be the result? 0, 1 and 1 is 0. 1, it's 2, right? 2 is 0 down, 1 up, right? It goes all the way back until the last one drops. Therefore, this plus this one becomes 0. That's how negative numbers are designed in computer science. You don't have a negative number. So what they did, they said instead of having a negative number, we're going to use the left bit as the sign. So if left bit is 1, it means this is a negative number. What is the value? Invert everything and add 1. Okay? Now, if you invert everything, it becomes what? 1, 0, 0, 0, 0 to the end, right? Add 1, becomes 2. Goes to the next one. You see what happens? So negative value of any number is inverting and adding 1 in binary. We don't have negative numbers. How do they keep it? They set the left one is 1. If the sign bit, they call it. That's why integer values, when they are unsigned, they are twice as big, because they are using that 1 big as value. They don't have any negative numbers anymore. But when you make it sign, an integer has 31 bits for the value and 1 bit for the sign. Therefore, it's half. And because the negative value has 1 extra bit to show the 1, that's why always negative values are 1 bigger than positive values, which matches math perfectly, because 0 cannot sit halfway through. 0 goes toward the positive side. Remember, I have to show you this. This is something that we do in IPC, but I'm going to do it in 345 now. So I say 10 fingers. Okay? This is 0. Therefore, it becomes 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, minus 5. Therefore, negative numbers are always 1 more than positive numbers. Got it? All right. And I'm old. Long time ago in a galaxy far, far away, when we wanted to actually keep values, to keep several different things inside one little integers, we use them as flags. The first one is if it's a male or a female. If the next 3 is number of children, because anybody has more than 16 children? And, you know, 8 children, like depending on what you want. So you keep going like that. So you could actually divide different pieces, okay? Now you know when you're actually opening a file why you put OR in the middle. Because when you OR, it combines the flags all together. So when you are saying open for input, it's second bit that is on. And then the other one is the fourth bit that is on. When you OR the two together, the second and the fourth bit is going to be on. That's why OR combines the flags together. You follow? Okay? So using this bit pattern, please try it and see how everything's going to go on. Okay? That's it for today. Questions? I thought we're going to go through it very quickly, but bitwise operators are going to be something that we need to talk about, I presume. Okay, I'll post the questions for the midterm, for quiz 4 and the midterm by the end of the week, so you have it for the next. Have yourself a beautiful day.